All right, back to solving quadratics. This is part 2. So remember, we talked about 5 different ways to solve quadratics, and we're now moving on to completing the square. So hopefully you watched part 1. If you haven't, go back and watch it. All right, so completing the square. Essentially, completing the square is a method to manipulate a quadratic that is in standard form to a quadratic that is in the form of, again, u squared equals c, where u is a linear factor squared. And if we can get it in this form, we could use the square root principle. So listen, what I'm trying to get across to you guys is if you want literally the easiest way ever to solve a quadratic, it's when you just say, take the square root of each side. Voila, you are officially done. Now, be careful here. 8 is unfactorable. It's not a perfect square root, but 4 times 2. So the 4 can come out as a 2, and there's a 2 left in there. So 2 square root of 2. So hopefully you guys understand that, right? Just reducing the square roots. But again, that is so easy to do, and I love it. It's so simple. So if I could make any quadratic look like that, then boy, it's really easy to solve. So that's what completing the square is all about. It's about making a quadratic in standard form look like this linear factor squared form that makes it really, really nice to do, okay? So the process can be fairly easy, or it can also be a little tricky, right? A lot of kids end up hating completing the square. It's like a swear word in the math community because kids just think it's so difficult. It's actually not. It's really easy for most problems. Some can be a little bit tricky, but if you just follow the process, it's not that bad. And the other thing that's really nice is, listen, it's always easy when the a value, the value in the term or the coefficient in front of the x squared is 1. It's always easy, but that's not always the case. But even if it's a 2 or 3 or 4, it's really not that bad. So let's talk about what completing the square is all about. I mean, this slide right here says it all. It really does. Okay, so if you have x squared plus bx plus this blue part is what you add in to complete the square, okay? So if you have an equation that is in this form, right? And this is pretty much standard form, right? Because it's all I did was move the c to the right-hand side. So if you're in this form, to complete the square, it's really simple. But there's a couple of things you got to note. To do this, the a has to be 1. So if the a is not 1, we're going to talk about that. You got to do a little bit of adjusting. But to do this method in of itself, you got to have that a be 1. All you got to do is look at the b value. Whatever that b value is, cut it in half. Come to the side, cut it in half. Write it down. b over 2. 6 divided by 2, 3. 8 divided by 2, 4. 10 divided by 2, 5. Write it down. Okay. Square that value and add it to both sides. That's it. That's easy. So because what you're doing, when you do that, when you take half of that b value and square it and add it on, what you're doing is you're creating what I call a perfect quadratic, right? Like, for example, x squared is x times x. That's perfect. X plus 3 squared, it's perfect. It's x plus 3 times x plus 3, right? It's easy. It's nice and perfect. It's not x plus 3 times x plus 2 or x plus 3 times x minus 5. That creates an unperfect quadratic. So a perfect quadratic is kind of like a perfect number. Like 9's a perfect number. Why? 3 times 3 is 9. 25 is a perfect number. Why? 5 times 5 is 25. So a perfect quadratic is when you can express it as a factor times itself. So x squared is perfect. X times x. X times itself. X plus 3 squared is perfect because it's x plus 3 times itself. X plus 3. So if I could force a quadratic to be perfect, it allows me to solve it a little bit easier. And it's really easy to force it to do that. Again, all you got to do is move the c to the other side for a hot minute, take the b value, cut it in half, square that number, add it on. Then all of a sudden, once you do that to both sides, on the right-hand side, you literally are just doing the add. Remember, b is a number. So at the end of the day, this is just a number once you do the math. You know, if it's, for example, if b is 10, 10 divided by 2 is 5, 5 squared is 25. All you got to do is add 25. That's easy. On the left-hand side here, now what you're doing is you're recognizing the fact that you have a perfect quadratic. So you have x plus b over 2 squared. And that's going to work out, right? That's always going to work. Because again, let's just make sure you understand this. It's x plus b over 2 times x plus b over 2, right? That's x plus b over 2 squared. So x times x makes the x squared. B over 2 times b over 2 is the b over 2 squared. And then on the outside, I have a b over 2x. On the inside, I have a b over 2x. And what's b over 2 plus b over 2? 2b over 2, which is just b. So it's going to work out, and that's why we like doing it, okay? Then once we're in this form of something linear squared equals a number, then you could just take the square root of both sides and you're like pretty much done. So I know that, in my mind, I just explained that as best as anybody in history has ever explained it, but I get that you might still be a little bit confused. So that's where examples are going to help. But follow the method. A needs to be 1. If it's not, we'll talk about that. It's actually really easy to fix. Then all you got to do is take half of that b value in the middle, square it, and add it to both sides, and you have completed the square. So let's look at a problem and see how this turns out. Okay, so the first thing is, I love the fact that there's a 1 right here. It's going to make my life a lot easier. One less thing to worry about. Then I always want to move the c value over to the other side. X squared plus 6x. And I'm going to leave a little gap right there. Remember, because I got to complete the square by putting something right there. I'm going to add the 5 to their side. Okay, so now I'm good to go. Now the method says take half of 6. So 6 divided by 2 is 3. That's a really good number I'm going to need. Now I got to square it, and that's 9. So I'm adding 9 to both sides. So first, algebraically, if I add 9 to both sides, haven't really done anything. But what I have done is I forced the left-hand side to be a perfect quadratic. Because x plus 3, that's my half number, the 3 is the half number, squared is x squared plus 6x plus 9. I made it perfect, right? Perfect, again, I tried to explain this earlier, perfect is the same factor times itself. X plus 3 times x plus 3. Again, FOIL it out if you don't believe me. X squared is x squared, 3 squared is 9, outside's a 3x, inside's a 3x, that makes a 6x in the middle. And on the right-hand side, I have a 14. Easy. You're done. I mean, that's completing the square. That's how simple it is. But now I want to finish solving the equation because now it's really easy to get rid of that square root. Oh, I'm sorry. I keep doing that. Second time I've done that. It's really easy to get rid of that square by just taking a square root. So take a square root of both sides, and you have x plus 3 on the left. The square and the square root inverse each other out. And again, the square root of 14, unfortunately, is, well, the square root of 14. But don't forget, I mentioned this earlier, anytime you create the square root in order to solve an equation, you got to add the plus or minus. Now, always take a hot minute, and kids that don't do this are going to lose points, and they're going to get mad, but I'm telling you now, make sure that if possible, you reduce that square root. The only factors of 14 are 7 times 2. Neither one of them is perfect, so I can't reduce it anymore. Always reduce. I'll just give you a quick example so you know what I'm talking about. The square root of 20. Oh, I don't want to ever see you leave that as an answer because 20 is 4 times 5. The 4 can come out as a 2, square root of 5. There is what I'd rather you have. So always reduce square roots. And again, I'm expecting you guys to know to do that. All right, so now to solve for x, all I got to do is subtract the 3 to the other side. So I get negative 3 plus or minus the square root of 14. So there's my 2 answers. Negative 3 plus the square root of 14. And by the way, that's irrational. The square root of 14 is not a perfect number. So I don't touch a calculator. I don't want no decimal approximation. I want the exact answer and then negative 3 minus the square root of 14. Those are the 2 answers once I was done solving. Again, once I get to this stage, oh my gosh, how easy is it to just take a square root of both sides and solve? It's so simple. But I got to complete the square to get there. That's where we need to complete the square. All right, now let's look at a much trickier one. But listen, if you know what you're doing, it's really not that tricky, guys. I promise. All right, so here we go. First thing, I'm not happy with the 4 right here, but you know what? I could figure that out in a minute. All right. I want to move the 17 to the other side. I always want to isolate my ax squared and my bx. So I'm going to subtract the 17 to the other side. All right, now listen, I don't want that 4 right there. So how do I get rid of that 4? Well, think mathematically. If I want to get rid of multiplying by 4, all I got to do is divide. That's the inverse of multiplication. Literally divide everything by 4. Everything's got to be divided by 4. Rules of algebra, guys. Got to do it to everybody to be fair. So that gets x squared minus 5x equals negative 17 fourths. Yeah, I created an ugly fraction, but you know what? Fractions are numbers too. They deserve to be loved and hugged. Can't ignore fractions. Okay, but now I got an a value that's 1. And as long as you divide everybody by 4, you're still okay. You're algebraically equivalent. All right, so now I'm ready to complete the square. My b value is -5. I got to cut it in half. That's an important number. I want that number. I love that number. All right, but I got to square it. And when you square it, first off, please note you're always going to get a positive when you square it, no matter if it's negative or positive. 25/4. So if I add 25/4 to the left, I got to add 25/4 to the right. All right, now, why did I do that? Because I'm going to create a perfect quadratic. X minus 5/2 quantity squared. Where did I get the 5/2 from? It was my half number. That's why I told you to write it down. Let me just prove to you that the green equals the red. Okay, if you need to do this, oh my gosh, do this. X minus 5/2, x minus 5/2, right? That's what x minus 5/2 squared means. X minus 5/2 times x minus 5/2. All right, distribute. X times x, there's the x squared. Last, negative 5/2 times negative 5/2, positive 25/4. Okay, that's awesome. Outside is 5/2. Inside 5/2. 5/2 x. I'm sorry, negative, I apologize. Negative 5/2 x on the outside, negative 5/2 x on the inside, negative 5/2 and another negative 5/2 is negative 10/2. Oh, negative 10/2 is negative 5x. So that's the middle. It worked out. Now, this is beautiful. I love common denominators. Negative 17 plus 25 is 8/4. Oh, but wait a minute. Oh my gosh. Come on. This is awesome. 8/4. 2. Come on. I mean, if you need to do that in 2 steps, by all means, go ahead. But come on. Negative 17 plus 25, common denominator. Add the numerators. 8/4, 2. Okay, so now look how easy this is to solve. Take the square root of the left, take the square root of the right. X minus 5/2 equals plus or minus the square root of 2. It's irrational. Can't do anything with it. Don't forget the plus or minus. Add the 5/2. My 2 answers are positive 5/2 plus the square root of 2, or, sorry, my messy handwriting, positive 5/2 minus the square root of 2, because the square root of 2 can be positive or negative. Bingo! Oh my gosh, so easy. I love it. Very, very simple. Even though I had a 4 in front, it was a little bit complicated there, but if you follow the procedure, it's very, very easy. All right, let's do one more here. All right. So once again, step 1 is always getting the ax squared and the bx by itself. I'm going to add the 5 to the other side. All right, now again, I don't like that 3 right there. The completing the square rule says I need a 1 right there. So I'm going to divide everything by 3. Everything gets divided by 3. X squared minus 4/3 x equals 5/3. Don't worry about fractions. Love them. Hug them. Okay. Now, here's where things get a little bit tricky because I got fractions. All right. But again, I love fractions. All right. So the first thing I do is I got to take negative 4/3. I got to cut it in half. Cutting it in half is multiplying by half. So that's negative 4/6, which is equivalent to negative 2/3. So that's my half number. Negative 4/3 cut in half. Excuse me. Cut in half is timesing it by half is negative 4/6 reduced to negative 2/3. That's my half number. I want that number. Then I got to square it. So I get positive 4/9, and that's what I got to add to both sides. Positive 4/9. All right, so on the left-hand side, I purposely created a perfect quadratic. So it's x minus 2/3 squared. Don't believe me? Multiply it out. X squared. Negative 2/3 squared is 4/9. Negative 2/3, another negative 2/3 on the outside and inside is negative 4/3. All right, now, okay, to add these, I got to get a common denominator. Come on, guys. Times both by 3 here, top and bottom. So that's 15/9. 15/9 plus 4/9. That's 19/9. Come on, easy. Simple math. Even though it's fractions, should be simple math. All right, get rid of the square root, or I get the third time I've done that. Take a square root to get rid of the square. And let's see here. I get x minus 2/3 equals, now listen, okay, plus or minus. Anytime you create a square root, you got to put the plus or minus. On the top, I get the square root of 19. That's clearly irrational. The square root of 19 cannot be reduced. It's not perfect. But on the bottom, the square root of 9 is a beautiful 3. So let me just turn it into a 3, right? Come on, make life easy. And there's only one more step left, and that is to add the 2/3. So I get 2/3 plus or minus the square root of 19/3. You know what you can even do if you really wanted to? Because you have a common denominator, 3, you could combine the numerators and do 2 plus or minus the square root of 19, all divided by 3. So there's your two answers. 2 plus the square root of 19, all divided by 3, or 2 minus the square root of 13, square root of 19, all divided by 3. Now, you don't have to combine it like that. I'm going to give you full credit if you would have left it like this, but understand how I did that. Now, again, to me, that's the hardest that it could get, and I don't really think it was that hard. All right, let's move on to the fourth option for solving a quadratic formula, and this is, I'm not going to lie, this is my favorite. It always works. It always works. Let me repeat that. It always works, no matter what. So if you want like a fail-safe method that's going to always work, use this. All right, so let's see here. Couple things. To use a quadratic formula, you got to have a 0 on one side. Duh, we've been seeing that a lot. You're always going to get two solutions because the formula does involve a plus or minus sign, right here. So you're going to get two answers, plus or minus. And it's way easier if the A, the B, and the C are integers. If the A, the B, and the C are fractions, yeah, or decimals, it's going to get tricky, not going to lie. But it will technically still work. So let's show you how easy this is. All right, so 2x squared plus 3x minus 1. All right, I already got a 0 on one side. This is so easy. Here's A, B, C. All right, here we go. X equals the opposite of B, which is negative 3, plus or minus B squared. Now, even if B was negative, you square it, you're still going to get a positive 9, always. Minus 4 times A times C. Now, I actually took my time to show that work there because, you never know. You want to take your time. If you're good enough to do that in your head, 4 times 2 times negative 1, go for it. But I like to take my time. All divided by twice A, 2 times A is 4. All right, let me clean this up a little bit. Negative 3 plus or minus. All right, let's see here. 4 times 2 is 8. 8 times negative 1 is negative 8. But 9 minus a negative 8 turns into 9 plus 8, which is 17, all divided by 4. I'm done. Just be careful at that middle. I get a lot of kids, especially when numbers get bigger, a lot of kids mess up the inside there. So just please be careful with that. Use a calculator if you really need to. Do handwork if you need to. Just be very careful. So I do have two answers. The first answer is negative 3 plus the square root of 17, all divided by 4. Don't go to your calculator because it's going to get some ugly decimal. I want exact answers. The second solution is negative 3 minus the square root of 17, all divided by 4. Couple important comments. Please listen. This number needs to be reduced. If it's perfect, like a 25, a 16, 81, well then duh, square root of 81 becomes a 9. Square root of 16 becomes a 4. Do it. If it's not perfect, make sure you reduce it. The 17 cannot be reduced. The only factors of 17 are 17 and 1. But if it's something like the square root of 24, that's reducible. I don't want that answer. 24 is not perfect, but it can be broken down. 24 is 4 times 6. That's 2 square root of 6. Because 4 times 6 is 24. The 4 can come out as a 2. The 6 is stuck in there. You better make sure you're doing that if you want to get final answers. Okay? Now, one more comment here as well with this problem is when you are using the quadratic formula, if you ever get a 0 inside of the square root, then that means there's only one answer. Because let's just say you have a negative 3 plus or minus the square root of 0 divided by 4. The square root of 0 is 0. Whether you add it, doesn't matter. Subtract it, doesn't matter. So your one and only one answer is negative 3/4. That's where there could be only one answer. If you get a negative inside that square root, stop right away. The problem is impossible. There are no solutions when a negative pops up in that square root. All right, guys, the only other method is the graphing method, which I did briefly mention at the in part 1. But remember, if you ever want to say, I kind of want to know if I got this problem right. I spent 10 minutes on it. I want to know if I'm right. Graph it. Type it into your calculator. Type it into Desmos. Look where the x-intercepts or the zeros are. Because if you look at a graph, wherever they cross, here and here, those are your zeros. Those are your solutions. So just check and make sure. Now, if you're using a calculator, if you're using Desmos, you might, when you check those, you might get a decimal. Okay, well, type them into the, type the -3 plus the square root of 17 divided by 4. Type in your calculator. That decimal should match up, is my point. You know what I'm saying? But that's a nice way to do it. So a lot of kids ask me, what's your favorite method? I just love completing the square because I love a challenge. I have heard my whole life, ever since I was your age, that completing the square is really hard. So I like to do it that way because I want a challenge. You know what I mean? That's the type of person I am. If you're not that type of person, then use the quadratic formula. It's going to always work. But when you do the completing the square method, if you follow the simple steps, as long as you don't mess up the math, it's really not that hard. I will say this. Kids that say, I can't complete the square, I hate it. You know what? It's not completing the square that's the problem. It's math. It's simple math that they're not good at. It's dealing with fractions. Oh my gosh, dividing by 3. I don't know what to do. Okay, that has nothing to do with completing the square. That's because you're bad with fractions. I don't know how to add 5/3 plus 4/9. That's not a completing the square problem. That's a fraction problem. So the point is, completing the square in of itself is really easy. The details are where you could get messed up. So just be careful, and I think you'll tend to love it like me. All right, guys, that's it for solving quadratics. Now, be careful because I can't tell you everything we do from this day forward might have a quadratic. Now, it might lead somewhere else, but you better be able to solve that quadratic with ease. All right, peace out. One of my favorite videos.